back to the next lecture, which we on geotechnical engineering. Right now, we are discussing about module one topics. As of now, we discussed about soil formation and the soil types based on the transporting agent, and then the weathering types like mechanical weathering and as well as chemical weathering. And then we also discussed about a few soil mass relationships. So, with the continuation to the previous topic, uh, the today topic is soil, water, and air relationships. In the previous lecture, last slide, we considered that the three-phase diagram. So, in the three-phase diagram, one phase is soil, second phase is water, and the other phase is air. So, combined, we call them as a three-phase diagram. So, continuing to the three-phase diagram, and this is the pictorial view of the three-phase diagram. So here we can see air completely one phase. It is a homogeneous that we will consider as a homogeneous entire one phase, and the other one is water, and the second one and the third one is solid. So in this there are fine aggregates and as well as coarse aggregates are maybe present. Fine aggregates and coarse aggregates are maybe present. So here if you total volume here this total volume is equal to volume of air plus volume of water plus volume of soil. Volume of air plus volume of water plus volume of soil. And the where volume of voids is nothing but volume of voids VV nothing but volume of voids. So it means volume of voids is equal to volume of air plus volume of water. Volume of voids is equal to what? Volume of air plus volume of water. And so coming to in terms of masses, so where we will consider mass of air is equal to 0 always. So it doesn't affect that much. So that's why we will consider mass of air is equal to 0 always while doing some exercises with this relationship. And mass of water is equal to this mass of water is equal to mass of W, and the other one is mass of soil. Mass of soil. These three masses we will consider, and as well as volumes are in terms of volume of air, volume of water, and volume of soils we will consider. So where volume of voids is nothing but volume of air plus volume of water. So those are the total mass is equal to now. So here how many phases? 3 phases. Where coming to the total masses, even though if you are not considering, so while writing we are supposed to write like this: mass of air plus mass of water plus mass of soil. Mass of soil. In specific cases, like if you are mentioning like strictly like air is equal to 0, in that case entire air portion becomes 0 and it is equal to only mass of water plus mass of soil. Also we can write like this: mass of water plus mass of soil only. And coming to the volume, total volume is nothing but, as I said, total volume is equal to volume of air plus volume of water plus volume of soil, and the volume of voids is equal to volume of soils plus as it is we can see here, as we considered volume of voids is equal to what? Volume of voids is equal to volume of air plus volume of water. So then total volume is equal to volume of air plus volume of water plus volume of soil. So here it is volume of voids is equal to volume of air plus water. So I just replace in total volume of air plus volume of water with volume of voids. So then the total volume again it becomes volume of voids plus volume of soil. So these are the various notations like mass of soil. MS is nothing but air, mass of soil, and MW is nothing but the mass of water and mass of air. Okay, so Vs is nothing but the mass of soil, V suffix S, whereas V suffix W is nothing but the mass of volume of water, and V suffix A is nothing but what? V suffix A is nothing but volume of air. So this is the entire. We must understand this. So with this relationship, so we are going to with this three-phase diagram, we are going to define few basic formulas that are the basic formulas with the help of these volumes and as well as with the help of these masses. So where total mass is nothing but to mass of air, mass of water, mass of soil. So we must remember this entire diagram for better understanding in the coming slides. So from the three-phase diagram, once if I draw this three-phase diagram here, so the three-phase diagram says that there are total 3 phases, in which the phase 1 is air and as well as water. Okay. So air, water and as well as soil. So volume of air, volume of water, volume of soil. So this becomes this is the entire, this one is volume of voids, volume of voids. And here the first definition in this is void ratio, where void ratio is nothing but void ratio is defined as the void ratio is defined as the ratio of volume of voids, ratio of what? Ratio of volume of voids to the volume of soil in the soil masses. So it is defined as the ratio of volume of voids to the volume of solids in the soil mass. So and it is denoted by the letter E. It is denoted by the symbol E, and it's generally expressed in decimal fractions. So it is expressed in like decimals, like 0 point, like that we will express this E. So we will not express the volume of this void ratio in terms of percentages. So here the mathematical formula of this is void ratio is equal to, so it is defined as the ratio of volume of voids to the volume of solids, volume of voids to the volume of soils. Then and as we discussed, this volume of voids is equal to what? Volume of air plus volume of water, volume of air plus volume of water. We can also write this formula. It is equal to volume of air plus volume of water divided by volume of soils. So this is the definition of void ratio, and it is denoted by the symbol small e, and we will express this void ratio in terms of decimals. And the other one is porosity. So the porosity is defined as the ratio of volume of voids to the volume of voids to the total volume of soil. So previously it was volume of solids of the soil mass. So here the porosity is defined as the ratio of volume of voids to the total volume, and it is denoted by the symbol N, and it is commonly expressed in terms of percentages. So not like decimals, it is expressed in terms of percentages. So mathematically, this porosity is indicated with the symbol small n, and this n is equal to volume of voids to the total volume, and we will express this is in terms of percentages. So we will express in terms of percentages. It is multiplied by 100. So here the volume of voids is equal to volume of air plus volume of water. So if we rewrite this formula, it becomes volume of air plus volume of water by total volume, so into 100. So again, if you want to elaborate in some detail, so total volume we can write like volume of air plus volume of water plus volume of soil. In this way also we can develop. So this is total volume, and this n is equal to volume of water plus volume of voids plus total volume in terms into 100. This is the porosity. Okay. And the other definition is degree of saturation. So where the degree is indicate that how much content is saturated from the given soil sample or from the taken soil sample. Okay. So the degree of saturation of soil mass is defined as the ratio of the volume of water. So it is the ratio of volume of water in the voids, volume of water in the voids. Like as I said, volume of voids is equal to volume of air plus volume of water. So degree of saturation is defined as the degree of saturation of a soil mass is defined as the ratio of volume of water in voids. So in voids with respect to the voids only. So in volume of water in voids to the volume of voids So and it is designated by the symbol S. And it is commonly expressed in terms of percentages. So it is defined as a ratio of volume of water to the volume of voids. So mathematically, so this degree of saturation is indicated with the symbol S. It is indicated with the symbol S, and this S is equal to volume of water to the volume of voids. So S is equal to volume of voids to the volume of water to the volume of voids is expressed in terms of percentages. So multiplied with 100. So this is the formula of degree of saturation. It is expressed with percentages. So volume of water to the volume of voids, and again volume of voids we can write like volume of air plus volume of water. Volume of air plus volume of water. So here there are conditions we must consider here, especially coming to the degree of saturation. So the degree of saturation actually, you can see when we call it as a dry soil, nothing. When we will call it as a dry soil. So whenever this degree of saturation S is equal to 0, whenever S is equal to 0. Suppose if you consider the three-phase diagram, here, so you can see the phase when S is equal to 0. In that case, when S is equal to 0 is nothing but there is no water content. So then this three-phase diagram becomes what? Only two phases. The phase one is air and the other one is solids. Phase one is air and the other one is solids. So whenever other case is fully saturated, this is the condition. So when S is equal to 100%, again the three-phase diagram becomes two-phase, but the phase one is water. Phase one is what? Water. So the condition one is for fully saturated. For fully saturated, in this case, S is equal to 100%. S is equal to what? 100%. Whereas for the partially saturated, nothing but S is equal to not 0, but there are some water content is present. That's why it ranges from 0 to 100. The degree of saturation, yes, it ranges from the 0 to 100. Okay, so coming to the next continuation to that conditions of degree of saturation, like case 1 is fully saturated and case 2 is partially saturated. As we can see in this case, whenever if you say like fully saturated, as you can see the fully saturated the two-phase system of the fully saturated condition, as we can see, air phase is absent completely. Air is completely absent in this case. So then it become only two-phase. And that is if you describe this in terms of mass, as we said, mass is equal to total mass is equal to mass of air plus mass of water plus mass of soil. But in this case, because of this fully saturated condition, as we consider this is equal to 100% air, so this air completely becomes 0, and the total mass becomes mass of water plus mass of soil only. So as you can see in terms of volume of voids, as of now we said that volume of voids is equal to volume of air plus volume of water. Here in this case of because of this degree of saturation is 100%, this volume of air becomes 0, and the volume of voids becomes only volume of water. Volume of voids becomes only what? Volume of water. So the other case, partially saturated, we can say it is like not partially, it is completely dry soil. So then in this case of dry soil, so then there is no water. So in the previous case, air is absent, but here water phase is completely absent. So then again mass of total mass becomes mass of air plus mass of soil. But what we said, mass of air will be considered as 0. Then in that case, total mass is equal to what? Mass of soil only. As you can see, total mass is equal to, in case if you consider air is equal to 0, again in terms of masses, if you consider the air is equal to 0, so then the total mass becomes only mass of soil. And in case of if you in terms of voids, the volume of voids is equal to volume of air plus volume of water plus volume of this is volume of voids only. So here, as we consider that here it is a dry saturated condition, and then water becomes 0, and the volume of voids is equal to what? Volume of voids is equal to volume of air only. Then the total volume becomes volume of voids plus volume of soils. So where volume of voids is nothing but what? Volume of voids is nothing but the volume of air. So total volume is equal to volume of air plus total volume. So in case of volume of soils, this is volume of soils. In case of when it is dry in condition, so in two cases, the three phase become two phase. So the first case is when if it is fully saturated condition, and the other one is when it is partially saturated condition. In these two cases, the three phase diagram become two phase only. Okay, so there are other few definitions you will get from this three phase diagram only. So in that, the first one is water content and the void ratio, as we already discussed. porosity, which is indicated with the N, and the degree of saturation. So then here we will discuss this in coming slides. So where void ratio is just void ratio is equal to E is equal to volume of voids to volume of soils, and here it is volume of voids to total volume. Okay, and this is expressed in terms of decimals, and whereas this is expressed in terms of percentages, and degree of saturation is also expressed in terms of percentages, and the degree of saturation S is equal to volume of water to the volume of voids. So volume of water to the volume of voids. So other definitions are air content, percentage of air, and this air content is indicated with the symbol AC, and the percentage of air is indicated with the symbol Na, where N suffix A, and the bulk density, and the other one is dry density, and this saturated density and the submerged density. So these densities, these are the formulas, the formulas of densities. We will the formulas of these densities we will also express in terms of unit weight also, as you can see. So bulk density, unit bulk density and mass density and mass weight, like that, weight of mass, like that we will discuss in terms of weight, and as well as we will discuss in terms of densities. So then as of now we discussed about void ratio, porosity, and degree of saturation. Now we will see the definition of the water content. Water content is indicated with the symbol W. So the water content is also called as moisture content, and in presence of water it is also called as moisture content. Then it is a measure of the water present in the soil. So as I said previously, it is a partially saturated. Actually that when we say that partially, nothing but there is some water content is present. So in order to measure that water content, we will use this water content in order to measure that percentage of presence of water within the soil mass. We will determine it with the water content formula. So this water content is defined as a ratio of the mass. Again, if you want to express this mass in terms of weight, again we are supposed to consider the weight also. So I'm just going with the mass only. So it is defined as the ratio of mass of water to the mass of solids. So it is defined as the ratio of what? It is water content is indicated the symbol W, and it is defined as the ratio of mass of water to the mass of solids. So here it is expressed in terms of percentages. Suppose in case if you want to express this in terms of weight, so it becomes weight of water to the weight of soils, again in terms of percentage. So this is in terms of mass and in terms of weight. So the water content we can express in terms of mass densities, and as well as other densities are also in terms of weight densities, and as well as mass also we can express, and those are expressed generally in terms of percentages. As we can see in this diagram, where we are discussing about this three phase, especially about the water content. So okay, so in nature the fine grained soil have higher value of natural moisture content compared to the coarse grained soil. So then in nature generally the soil formation will occur through nature only. In that if you take that criteria about to discuss about the water content, generally in fine grained soils have higher moisture content compared to the coarse grained soils. So the water content is always greater than or equal to 0. So right. So other definition is air content, and the air content is indicated with the symbol A suffix C, where the air content is expressed in terms of percentages, and it is defined as the ratio of volume of air to the volume of voids. It is defined as the ratio of volume of air, nothing but V suffix A, and the volume of voids is nothing but V suffix B. So it is defined as, it is expressed in terms of percentages. And the range of this air content is 0 less than or equal to AC less than or equal to 100%. The range of the air content is, it is vary from between 0 to 100, where it is also expressed in terms of percentages. As we can see the mathematical formula of this AC, volume of air. So it is defined as the ratio of volume of air to the volume of voids. So volume of air divided by the volume of voids into 100. So other one is other definition is percentage of air voids. It is indicated the symbol N suffix A, N suffix A, and this percentage of air voids is actually act as a measure of the air volume present in the soil mass. So this percentage of air voids, so this is the water phase and this is the solid phase. So this percentage of air voids is actually used to measure the air volume present in the soil. Okay, air volume that is present in the soil mass. So it is defined as a ratio of volume of air. It is defined as a ratio of volume of air to the total volume. So to the total volume. So mathematically, and this is N suffix A. It is N suffix A, volume of air to the total volume, and it is also expressed in terms of percentages. The range of this percentage of air is between 0 to Na and less than or equal to 100%. So less than or equal to 100%. The range of this one is, so where percentage of air content is AC is equal to volume of air to the volume of voids. Na is equal to volume of air to the volume of total volume of air to the total volume. So both are expressed in terms of percentages. Okay. So as densities, coming to the densities, the basic formula of the density is equal to mass by volume, where it is denoted by the symbol rho. Density is denoted by the symbol rho. It is mass by volume in mass by volume, and the units of the density is kg per meter cube or grams per centimeter cube and tons per meter cube. So this is the density, and it is denoted by the symbol rho, mass by volume. Suppose if you want to express in terms of weight, so it becomes gamma is equal to weight by volume. So it is, whereas in this case of densities it is rho is equal to mass by volume, and whereas in this case of in terms of weight, gamma is equal to weight by volume. So here again the weight of soil in kilonewtons, previously mass of soil in kgs. Okay, so we are expressing in terms of weight, and this weight by volume, weight of soil in kilonewtons and the volume of soil in terms of meter cube. That the units of this it is equal to kilonewton per meter cube. As we know that the conversion between the mass densities into weight densities, so multiply with a 9.81. So it is in meter per second per G. G is nothing but what? Gravitational constant. Okay. So this is the way of conversion. So we will get 9.81 kilonewton per meter cube in terms of, if you want to convert from the masses into the weight, and approximately it is equal to 10 kilonewton per meter cube. So continuation to that volume mass relationships. So the volume mass or volume weight relationships. So as the three-phase diagram, having right side is masses and the left side is volumes. There masses we discussed in mass, we can the masses sometimes wherever it is required we will convert into the weights. So as we seen already conversion also. So then the densities, these are the few formulas of mass densities. The first formula is bulk density, dry density, and as well as saturated density. So we can also call it as bulk mass density, dry mass density, saturated mass density. So the bulk density is equal to density is equal to rho by volume. The bulk density is equal to mass by volume, whereas this dry density is equal to mass of soil. Specifically, we are talking about the dry density. So we will consider only the mass of soil by total volume. Again, the three-phase diagram says what? So where mass is nothing but mass of air plus mass of water plus mass of soil. Mass of air plus mass of water plus mass of soil. And in this case of dry mass density, out of these three components, we will consider only the mass of soil and to the total volume. So dry mass density is defined as the ratio of mass of soil to the total volume, and it is denoted by the symbol rho suffix d. So coming to the same dry density in terms of dry unit weight. So rho becomes gamma, like in this case gamma d, and weight of soils by the volume. So this bulk density, here it is rho is equal to mass by volume. Here gamma is equal to weight by volume. As we considered masses, in case of this mass, all three components of air, water and soil in terms of mass. And coming to here, this becomes weight of total weight is equal to Total weight is equal to weight of air plus weight of soil plus weight of water plus weight of soil. So then again, whenever in this case, if it is becomes 0 and this W is equal to only water plus weight of soil only. So these are the densities formulas, and the other one is saturated density. So like the saturated, what we will use whenever there is a presence of some moisture content within the soil mass. So this saturated density is indicated with the symbol gamma saturated, like rho saturated in terms of densities, and it is equal to mass of saturated divided by the saturated density formula is equal to, it is defined as a ratio of mass of saturated to the total volume of solids. So whereas this saturated density in terms of saturated weight, so this becomes gamma saturated, and it is defined as a ratio of weight of saturated to the weight of saturated to the total volume. This is the way of representing in terms of mass and as well as in terms of density. Suppose if you take any problem, in that problem they may ask you to sometimes determine in terms of weight densities like that. So we must understand these concepts. So how we are converting from mass densities into the weight densities by taking that constant, gravitational constant 9.81 kN per meter cube. Okay, so the continuation to the previous slide, it is the other density is submerged density, or we can also call it as a buoyant density, or as well as effective density. Where the submerged density is nothing but if you the soil sample, like if you take this soil sample, so it is if you say if you if you say this is water, okay, this is the water, and here then some soil mass is kept, it is submerged within the water, and opposite there is a force is acting that we call as a buoyant force. So that's why we will do rho W minus in this case. So the submerged density, the symbol we will use gamma dash. The submerged density symbol we will use gamma dash, and it is equal to gamma saturated minus gamma W, rho saturated minus rho W. The formula of this one is rho saturated minus. There is a derivation to get this formula that we will see in the coming slides of those derivations. So here it is also denoted by the symbol gamma dash or rho dash or rho submerged. So the definition of this one is rho saturated minus rho W. The mathematical formula of this submerged density is what? Rho saturated minus rho W. Okay, now this is the conversion, and coming to the in terms of unit weight, it is equal to gamma saturated minus gamma W. So again same conversion we will use, and again the other density formula is density of solids. So here it is mass of solids by the total volume. Density of solids is denoted by the rho suffix s, and it is defined as the ratio of mass of soils to the volume of soils. It is defined as the ratio of mass of soils to the volume of soil. So whereas in this case of densities in terms of density of solid in terms of weight, so it becomes unit weight of the solid, and it is equal to gamma s is equal to weight of soils to the volume of soils. Okay, so other one is specific gravity, G. Specific gravity is indicated with the symbol G, and it is defined as the ratio of the specific gravity is indicated with the symbol G. It is defined as the ratio of weight of the given solids to the weight of an equivalent volume at 4 degrees Celsius. At which degree Celsius is at the weight of the equivalent volume of water is at 4 degrees Celsius. Is that what? The specific gravity is indicated with the symbol G, and it is defined as the ratio of the weight of the given solids to the weight of an equivalent volume of water, and this particularly at 4 degrees Celsius. Okay, so where this J is equal to specific gravity indicates the symbol G, and this G is equal to weight of solids into this weight of solids into gamma W. Okay, so the G is varies from 2.65 to 2.80 for all type of soils. For all type of soil, the G is vary from the 2.65 to 2.80, except to some organic material that we will see the value of those organic. If any organic matter is present in the soil mass, then the G value is slightly reduced. So that also we will see. So these are the various densities as we discussed. bulk density, dry density, saturated density, submerged density, dry density of solids, and as well as the specific gravity. So these densities are in terms of weight is bulk unit weight, dry unit weight, saturated unit weight, and then submerged unit weight and unit weight of the solids. Okay, so again, this is the some functional relationship between the E and as well as N. E and as well as N. So as we discussed, E is nothing but void ratio, and this volume of voids is equal to volume of soils. The formula of E, basic formula of E from the three-phase diagram which we obtained, it is volume of voids to volume of soils, and the where N is nothing but the porosity. N is nothing but porosity, and it is equal to volume of voids to total volume. Volume of voids to total volume, and it is expressed in terms of percentages, whereas E is expressed in terms of decimals. So now the relationship between the E and N, if you see, we will get from E is equal to, from E, the relationship between E and N, E and N, from E is equal to, we will get N by 1 minus N, or we will get N by 1 minus N. From N is equal to E by 1 plus E. From N is equal to E by 1 plus E. As we can see, the entire relationship, like the from the basic formula, how we derived this E. So V basic formula is volume of voids to volume of soils. E basic formula is what? Volume of soils, volume of voids to volume of soil. As we all of you, we know that volume of voids, we can write volume of air plus volume of water. You can write what? Volume of air plus volume of water. And this total volume. So total volume is nothing but volume of air plus volume of water plus volume of soil. Okay. So where volume of voids is equal to volume of air plus volume of water. So we can write V minus Vs is equal to V minus Vv. So where total V is nothing but total volume, and V suffix V is nothing but the volume of voids. So from here, so when if you consider like 1 by E, it becomes V minus Vv by volume of voids. So then again this volume of voids becomes 1, and then as we know that the porosity formula is equal to volume of voids to total volume. So this is porosity, and here I can consider this is the inverse of the porosity, like 1 by N minus 1. So from this, finally we will get E is equal to N by E is equal to N by 1 minus N. So this is the relationship we obtained between the void ratio and porosity in terms of E. Now we will see in terms of N. So same procedure, as we consider the basic formula of N is equal to V, volume of voids by total volume. So volume of voids I can write in terms of volume of air plus volume of water, whereas this total volume I can write the volume of soil plus volume of voids. Again, this volume of voids is nothing but volume of air plus volume of water. So all these basic definitions need to be remembered to understand the concept too deeply. So here, once after solving this relationship, finally we will get what? We will get the relationship between the void ratio and porosity in terms of N, where N is equal to void ratio, and the relationship between E and N, it is by E by 1 plus E. E by 1 plus E. This is the relationship we will get from the in terms of N. The void ratio formula previously, it is only E is equal to volume of voids to volume of volume of soil. Now from this relationship, another formula of E is equal to what? That E is equal to N by 1 minus N. N by 1 minus N. Okay, 1 minus N. So from this relationship which we obtained, that is N is equal to, we know that volume of voids by total volume. Again from this relationship, N is equal to E by 1 plus E. See, like this we will get some few formulas. Those are significantly we will use in the coming problems. While solving the problems, we will use this basic definition and these concepts, and as a conversion into densities and as well as the mass densities. So coming to summary. So before concluding, I just want to give some summary. So we discussed about the basic definitions of the void ratio, and the definition of the porosity, and the definition of degree of saturation, definition of water content, okay, and the definition of air content, and definition of percentage of air, and the density, and the dry mass density, submerged density, saturated density we discussed, and the finally what we discussed between we discussed the relationship between relationship between relationship between what, between E and N, what we obtained from E is equal to N by 1 minus N, and from N is equal to E by 1 plus E. So with this I'm closing this topic, and we will see in the we will meet in the coming lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.